Good afternoon, everyone. In this video, we are going to discuss one of the questions under metals extracted from 2012 past paper. Here is the question that we are going to work out together. Let's begin. The list below shows metals arranged in ascending order of reactivity: silver, zinc, aluminium, and sodium. Using metals from this list only, name a metal which can be displaced by copper. So here we are restricted. We are told only to use the metals that are listed here. So now to answer question A, you need first to understand the meaning of the word displaced or displace. So to displace, it means to take over a place, position, or a row. That is what it means by to displace. That is displacement. The displace means to take over place or position or a row. Now, copper is not among the list. Why is it in the question? So now, to answer this question, you need to understand the reactivity series of metals. The reactivity series of metals, if you don't remember well, let me remind you. Here is the reactivity series of metals from the most top, the most reactive top, to the least reactive metal at the bottom there. So potassium is the most reactive in this reactivity series, and got there, that is the least reactive metal or in this reactivity series. So this is the common reactivity that we use. So now they want us to determine a metal that can be displaced by copper. So what it means there is the most reactive metal will displace the least reactive metal. So meaning here, in this case, we are going to compare this with the list that we have here. So in this case, we have sodium. So it shows that sodium is the most reactive element or metal in this list that we have there. So we have sodium there. Then if you follow carefully using this reactivity series, aluminium will follow, and then zinc. Then finally, we have silver. So when you check here, this question, it is saying a metal that can be displaced by copper. Where is copper in the reactivity series? Copper is here. So now you will check whatever is above copper. Copper cannot displace those metals because those metals are highly reactive. So copper will only displace metal that are least, that are low in their reactivity series. So in this case, copper will only displace what is under copper. So copper, whatever is under copper, copper will be able to displace those metals. But whatever is above copper, copper cannot displace those metals because copper cannot displace the most reactive metals. So in this case, whatever is below, so from our list here, we can see that silver is below copper. So meaning copper can only displace silver according to our list. So the answer there will be silver. Coming to B, a metal which reacts with cold water to produce an alkali solution. So here also you need to understand the concept that it is only the most reactive metals that will react with cold water. These other metals, they don't react with the cold water. So now, using our reactivity series here, the first four metals, these are the most reactive metals, and these are the only metals that can react with the cold water. So to list them, these are the four. We have potassium, sodium, calcium, and also magnesium. So if you try to compare this with the list given here, we can only see one metal which is appearing in this list which reacts with cold water. So the answer there now is sodium, because sodium is among those four metals that react with cold water. So the answer there is sodium. Coming to C, a metal which forms an phosphoric oxide when bent. So you need to understand the meaning of phosphoric. This word, it means that properties, it has properties of acidic and also basic. That is what it means. So when we say a phosphoric oxide, we mean an oxide that possesses properties of acidic and also basic. That is what we mean there. So there the answer is zinc. So it is zinc that the zinc oxide possesses properties of acidic and also basic. So now in summary, for these three questions, our answers: A, we have silver; B, we have sodium; and then C, we have zinc. Coming to D. A metal whose carbonate does not decompose when heated. A metal whose carbonate does not decompose when heated. So here, class, the metal whose carbonate does not decompose when heated. Here, for the most reactive metals, their carbonates, they usually don't decompose because it is reactive. So now when we compare the list, the most reactive metal that we have there, it is sodium. So meaning the carbonate of sodium cannot decompose because sodium is the most reactive metal there. So the answer there is sodium. Coming to E, a metal which forms a stable oxide layer. So the answer there, it is aluminium, because aluminium reacts with air, with oxygen in the air to produce aluminium oxide. That oxide layer is very stable and it acts as a protective coating by preventing further reaction of aluminium. So the answer there is aluminium. Coming to F, write a balanced chemical equation for the reaction between sodium and water. So remember we said sodium is the most reactive element. It is the highly reactive metal. So meaning it is capable of reacting with water. So now other key elements that you should know about reaction is that, one, when a metal reacts with water, you should know what it produces. So in this case, when a metal reacts with water, this is what it produces. It produces metal hydroxide and the hydrogen gas, meaning two substances will be formed: metal hydroxide and the hydrogen gas. So now, the same time, if they ask you to say a reaction or to write a reaction between a metal and steam. So now this is the solution that you get. A metal plus steam, it gives you metal oxide and the hydrogen gas. I've given these 2 points because water and steam, we write them the same. The H2O, they are the same. So here now, in word, that is where we get to understand them, to say, oh, this is cold water and this is steam. But when writing a chemical formula, the formula is just the same. So if it is reacting with steam, it will produce metal oxide and the hydrogen gas. But if it is reacting with water, then it is going to produce metal hydroxide plus the hydrogen gas. So in this case, we have a metal and cold water. So meaning we are going to form the metal hydroxide and the hydrogen gas. So the metal there is sodium, meaning we are going to have sodium hydroxide plus hydrogen gas. So this is what we are going to do. That is sodium plus water. So you've seen the way we've written water. This is how we also write steam. No wonder I brought these 2 points. So now this is water giving us sodium hydroxide plus the hydrogen gas. So you have to make sure that it is balanced. So we are going to balance it. The first thing, you need to check the atoms. You need to identify the atoms in this. So we have sodium, we have hydrogen, we also have the oxygen there. From there, you're going to determine, we are checking it out to see whether it is balanced or not. So sodium, this side, the first side, we have 1. The other side also, we have 1. Coming to hydrogen, here we have 2. The other side also, we have 1, 2, that is 3. Then coming to oxygen, we have 1. The other side also 1. And that simply, we have a deficiency of hydrogen atom to the left-hand side, where we have 2, the other side we have 3. So we have to make sure that we balance it. So now, when you check this equation, the first side, there's a deficit of 1 hydrogen atom. So meaning it needs 1 hydrogen. So when balancing, we don't use number 1, but we use numbers above 1. So you cannot add a 1 in front there because it still remains the same. So henceforth, we are going to increase the number of hydrogen atoms to the right-hand side so that here we use a bigger number. So meaning we are going to add 2 to the sodium hydroxide and also 2 to okay, let's do this. This is what we are going to do. You add 2 there to you add 2 to sodium hydroxide so that the sodium becomes 2. You also add 2 to sodium this side so that the sodium becomes 2. Then when you look at the hydrogen atoms has increased to the right hand side. And also when you look at oxygen has also increased by 2. So meaning there's also need to add a 2 to water. So if you add a 2 to water, then your equation is balanced. That is what you should do. And also make sure that you include the state symbols. Sodium is a metal, remember, it will possess a solid state, a solid state symbol. Then the water here, this is water, it is liquid. Sorry that it is not shown there, but you include L, small letter L. Then the sodium hydroxide, that is aqueous. So you write like that, and then the gas there, it is small letter G. So here also on the balanced chemical equation, make sure that you include a 2 to water so that it balances correctly. Thank you so much for watching this video.